We're going to do a little bit of reminiscing today. Not a lot, just enough to get some context. I can remember back in the 1990s when client server became all the rage. Suddenly there was this way for people to work, not sitting up next to the machine, not in the cold white room, which honestly I would have preferred. But there was a kind of golden era. And in that time, our customers needed us. They kind of knew what they wanted to do, but it was up to us to help modernize and automate. They would come to the software professionals and say, please, can you help me? They said, well, let me show you what's possible and we'll figure out how to make that work for you. And we kind of drove that. During that period, there was the ability to understand the business and guide them was a shared activity, but generally we led and, they paid. Good times. But now those businesses had been maturing, and when you come off the 1990s into the early 2000s, we start to see people own their own data centers. And I know that this is sounding like, well, of course, everybody knows this, but the key part of this is that in those data centers, they controlled capacity, they controlled security, and they had strategy that was about how to work with these things they built, these real brick and mortar buildings with deep, expensive investments in hardware, and they had to manage all that. For them, at the time, the network was a security boundary. If you couldn't log in, you were safe. Everybody on the inside stayed inside, and people on the outside largely stayed outside. Our customers, they weren't really part of the IT conversation as much. The IT teams were separate, driving the sort of infrastructure and plumbing and being very important in the business because it was providing new revenue and new capability. It was really hard for the customer to engage in that conversation because it was deeply technical. We worried about, layer 7 traffic, not whether or not you could do your accounting. People like me and outside consultants, we were brought in and we were put under contract. And I mention that because the contracts were a result of fear. Fear in that era was because people charged customers a tremendous amount of money and very often failed to deliver. They would get towards the end of burning, whether it's thousands of dollars or millions of dollars, and say, but you didn't tell me, we didn't know. And up front, we made these assumptions, and since they're not true, I'm just going to walk away with the money you've given me. That's kind of how my work was born, as I got called after that moment and had to figure out how to make it work anyway. But in that fear and reaction, we created this constrained environment that bred the need to know upfront and write on paper upfront what was going to happen. But, that's all history. Let's kind of get into what's going on now. I bring up Vuca, which is volatility, uncertainty, complexity, and ambiguity. Just rolls right off the tongue because it's what's driving the transition. All of that history that's rolled up to right now has created these attributes, these things where we used to do risk management and change control and create stable state, and it's gone. Now risk is continuous and change is continuous and complexity is off the hook high and ambiguity is just par for the course. But this happened because there was a shift. The shift was from the IT pro driving the customers to take advantage of a thing to a customer saying, I want, I need, and you need to make it work. So they began leading us. It was a complete inversion of the economy. It didn't go over well. Honestly, at the very beginning, we were interchangeable widgets. People who wrote software were given a problem definition, sat in a corner, said, do it. And if I failed, somebody else would come in behind me. That was the birth of Agile. Agile was a bunch of people who said, you need to treat us like people. You need to humanize this craft. And software development was, and in large part may still be, craft. It became a reason, Agile, not the excuse to push things to the right. It was that because we didn't know, we used the cone of uncertainty, we move things into the future, we'll get to it, figure it out with more detail. Once we were on top of it, we do better work. But it became a reason to blame the customer. I may say some disparaging things about Scrum. I apologize to all of you who love Scrum. But Scrum was the leader of this sort of framework of process that became really, really, really deeply engaged in the business. And at one point, 5-10 years ago, the product owner was invented. And I do mean invented. It was never, nobody really called our customers or our users product owners until then. And then product owner training came out. And the reason we couldn't do this well was because our product owners, our customers, they didn't know how to talk to us. So we were going to charge them to learn how to talk to us, then charge them to be included as part of the workload, and charge them again until essentially they ran out of money, and that was the last sprint. I admit I'm making a little bit of fun of it, but the way we built things was different. There was no fixed outcome. In that, we created additional complexity and additional iterations, and ultimately, for a long time, ignored architecture. I am a software architect. That's what I do for a living, so I've got a bit of a bias. But architecture looks at the entirety of a thing and creates all the puzzle pieces, even though you may only build small parts of it initially. And when Scrum teams came out, they focused on the minimum viable product, something else I have concern with, because it is badly defined. Instead, we ended up with misunderstandings. But before I get too far down that rant, and it's a bit of a rant, let me get into some of the definitions that we're going to use today. Vuca, the first one is volatility. And I pulled these definitions straight out of the Cambridge Dictionary for anybody who'd like to follow up. Reading a dictionary is great fun. Volatility is the likelihood of change. It's really not a question of if, but when. And that's what's happened in our world. We don't manage risk anymore. We assume it, that risk will always be there. And as a certainty, we've built processes around it like Scrum to handle that. We've built small teams. We cut things into little parts. The big model up front, requirements-driven waterfall stuff has fallen out of favor. And I understand that. And, old guy. We used to do it when it was small problems, relatively simple problems compared to today. But at the same time, they helped us to find a completeness, an acceptance level that we don't really do much anymore. Safe and disciplined agile, they're starting to bring some of these practices back. And I think it's a good thing. We're kind of swinging the pendulum backwards a bit. But we simply don't know what's wanted or even how to describe it is a highly suspect thing, because that description is volatile. The time it takes to build software exceeds the time it takes a person to change their mind. And frequently our sponsors in a business will come in absolutely certain what they want to do. We feel like we've got clarity. We start doing work, and then that executive rolls out. Another one comes in, new point of view. And at that moment, volatility happens. And we have to deal with that change because we couldn't deliver what was asked in the time available, because we didn't really look at the time available as part of consistency. We looked at it as how long would it take me and my team, so to speak, to get things done. So to beat volatility, we just need to build faster than the changes around us, or at least suppress the changes enough that we can meet them where they are. Next up is uncertainty. I don't know what that means. Okay, that's a terrible joke. Uncertainty is defined, and hilariously, it's defined with the word certain in it, so that it is something that is not known or certain. Uncertainty is an epidemic in our business. Every piece of software I've ever touched, and bear in mind, my bias again is I see bad projects. I never see the really great ones. They have been uncertain from the very first day as to what the result will be. And the ability to deliver a predicted scope on time and within budget has become, in essence, a myth. It's lore in the industry. It's a modern day miracle when it happens that you knew enough to estimate well, deliver consistently, and stay within those original terms. Excuse me, that's high art today. Without defined scope, there really can be no planned success. There's just planned activity. And if we include people in the process, we can virtually guarantee that the work will continue indefinitely. The people who serve us as customers is backwards. We need to serve them. And part of what we do, bringing that expertise that used to be that thing that led the customer in the past, bringing that back to the forefront allows us to listen to them and include them, but treat them in a way that allows us to reduce their fear and give them greater certainty. Complexity, and there's a large school of science around complexity. For me, it's defined by a thing called the Cynefin framework. So in this framework, there's simple things, which are known problems and known solutions. And there are complicated things, which are known or unknown problems with known solutions. And complex things are unknown problems with unknown solutions. The first one you can solve through instructions. If it's simple, you look it up and you do what the instructions say. If it's complicated, you tend to deal with it through knowledge. I'm aware of this thing. I can go find the answer. It's been solved. I'm going to redo that. Complex things require experience because there is no reference point. It's something that's new. By our customers coming to us with all of these things that they thought they should be able to do, but we've never even tried, they create problems that we've never seen. And that complexity, the number of moving parts that are required and the number of parts demanded by the customer, that drives us into these dark alleys where we really don't know where we're going, but we know somewhere down there, there's a door. And our job is to get there, well, faster than they can change. There are a couple simple rules around complexity. Complex problems have complex solutions. And if there's any quote of the day out of all of this, please write that one down. Complex problems have complex solutions. If you think you have a simple answer to a complex problem, one of the sides is wrong. Either it isn't complex, it's simple, or it's not simple, you're not working it out. And the only corollary I would add to this is complex solutions require real work, not shortcuts. Consistently, just do the work. Most of the projects I come to that are broken, the problem is they gave up. It wasn't that they didn't know how, they just got tired of doing the work. And they were looking for a shortcut out, and those shortcuts turn into what we call technical debt. And technical debt will eat you alive in a long-term, large-scale program. Last word, ambiguity. It is the foundation that moves engineering to art. And I know we talk about it the other way all the time, where we go from art to engineering. But the reality is we've gone past that point and swung back. Engineering is ones and zeros. And God knows we love doing things that way, where there's a logical, gated piece of code. It does a thing and it does it the same way every time it's run, and it's a beautiful piece of engineering. But the problems we're trying to solve are human problems, and they're not engineering problems. We're trying to find a way to bridge that gap, and that turns out to be art. And none of these choices and word order and coding and well-meaning discipline, none of them solve an open-ended problem. Open-ended problems require highly dynamic systems and self-learning systems, and nowadays we're getting towards AI. But when you ask somebody, how many users do you need to support for an internet-facing application? Who can pick a number? Who knows how popular it will be or not? Who knows how many people on the other side of the world will get to it or not because they can? It's literally unknowable. And scaling for something like that becomes unknowable too. You can build this thing that scales really well in hopes, or maybe you start really small. You come up with strategies, not answers. If there's an outage in the cloud, it's like a tree falling in the woods, no one hears it. The cloud will shift you from one machine to the next. You don't own machines, you don't manage machines, can't hug your hard drives. It just happens. And even while this great math is in place, it's these dynamic interactions that determine the real outcome. So let's get into what bad software looks like today. We live in the world of zombie apocalypse, right? We have zombie software. It was written, it should have died, and it hasn't. It still has users, and it still haunts your network and your people. The zombie apocalypse, in this case, the zombies won. The world is overrun with dying software that doesn't know it should be dead yet. It has limitations that people have propped up. They've added new pieces to it. They've grown it kind of organically. They put bubblegum and tape on the thing just to keep it up because it feels too hard to fix. And it gets harder to fix and harder to maintain and becomes a bigger zombie horde. It may function, but generally speaking, it doesn't function as well as people want it to. And because of these things that have sort of bound it together over time, it's gotten to be expensive, really, really expensive. And people generally forget the cost of that because, again, It's technical debt. It builds up over time. Zombie software is fragile. Frequently, there's no original source code or certainly no original coders who can go back in and understand the reasoning for a thing. Why is it like that now? The business is usually changed underneath it. It's usually one giant monolithic piece of goop. And there's actually a great reference to this called ball of mud, where you just take a ball of mud and you put more mud on and more mud on, and eventually get this giant ball of mud. This organic growth is without intent or limit. And being intentional is part of the way to get out of the mess. The reality is, in the zombie world, there's only one way to kill it, and that's to cut its funding off. As long as somebody is out there trying to use a thing and there's no penalty for using it and it's getting money, it's going to keep growing. And the horde gets bigger and takes over more of your network and more of your time. But organic growth, I mean, it is a reality. It's what we need to deal with. If you go and look for these things and you look to get ahead of them before they become truly the Walking Dead, there is evidence of what works and what doesn't. A sort of pre-modern application that's highly functional frequently shows up as centralized or standards driven. This is a fave for me. I do a lot of really big systems. I do it for governments. I do it for large organizations, pseudo government things. Every time they love their standards and they think if I can make my 1,600 developers all comply with a standard, this will be fine. We'll all interoperate because we're on a standard. But as it turns out, there's a remarkably large number of standards, and it doesn't make sense. Centralization and standardization in large enterprise systems has, in my opinion, never worked. What it allowed to do is allowed the zombie horde to get bigger. And more people sort of glommed on and said, well, I'm in the standard, but I'm a special snowflake, so I'm going to do this other thing. Nowadays, if you find these things running in a private data center, it's also a pretty big red flag. The cost of running a data center, of owning the stack from the actual concrete floor all the way through the network to the user desktop, is, compared to hosting out in the cloud, exceptionally expensive. It wasn't that long ago that people couldn't start businesses because they couldn't afford to set up the data center. They couldn't afford to hold the giant data set they needed to do analysis on or whatever the problem of the day was. Now for $20, I can get out in front of everybody in the world in a day. And all the infrastructure, whether it's a website hosting your front end or the Cosmo DB in the back end providing consistent data globally all at one time. It's, to an application user, unbelievably cheap. Matter of fact, it is so cheap now to do storage that all the relational data systems we used to do to keep our storage small, they're all being done on flat storage types. The new databases don't have all that relational infrastructure because it's just overhead. And the cost of storage is close to zero. So if I see somebody who's got this really complex query and their stuff is running really slowly, the first question is, why are you doing it that way? Right? You're telling me it's really hard to row your canoe upstream to deliver your goods, and you're standing in front of a highway. Get in the highway, lease a truck, get a truck driver to pull your stuff, and it'll be done in a minute. Don't buy into the old way. The other thing that is a big piece of post-modern, pre-modern workloads is how people interact with these systems. Again, it wasn't that long ago that people had to be on the network to do what they wanted. And now we all carry these computers in our pockets called phones. And those phones are connected through a generic system to a bunch of other connections that nobody really knows about, but like magically works. And there's all kinds of systems in place to make that possible. But if you have an enterprise who has a paranoid set of controls that says you must be on my network or you must be on my desktop or your hardware must be managed by me, you should go looking around for the zombies in the corner because they're there. And they're going to come creeping out in the middle of the night when somebody needs to get something done but can't get access to a system. And you find out you've got this giant tier 1, 2, and 3 support infrastructure that costs you a huge amount of money that would have gone away if that person could have picked up their phone, gotten to a remote site, and done their work. Those costs, they're just not being tracked well right now because you need telemetry to do that. If you don't have telemetry in a system, you should also be looking for the zombies, because telemetry is the sound of zombies dying. It allows you to know what's happening everywhere, to do reporting on that in real time, and have automated systems react. The last of this is, I shouldn't say this too loudly because I sit on a bunch of boards, but if you have an architectural control board or a business review board or a standing steering committee, or pick your flavor of these things, they're there because they are part of oversight, and they are part of centralizing command, or command hierarchy at the very least. Again, centralization, not a good thing right now. If you can move control all the way down to the developer, as far down as you get, to allow decision-making to be made by people who are exceptionally skilled, they're going to make good decisions. And then you use all these other management structures to deal with the anomaly, the unusual case of them not doing well or not knowing what to do. This is the move from the alpha leader who was in command to sort of the beta conductor who helps the orchestra come together and make beautiful music. In the latter, the skill is in the instruments, the individual players who know how to work together, who in real time are kind of figuring it out, but they need a little bit of guidance to keep them together. And that's a conductor. Making that shift in leadership is a cultural shift, but it's also what keeps people at bay. Now, I'm not the only one who's sort of looking at this giant change. Obviously, there are big organizations out there. One of my favorite is Gartner. Gartner has come up with the 6 R's. It's probably a couple of years old now, and says if you're moving from a legacy system to a brand new, shiny, cloud-hosted kind of thing, these are your options: rehost, replatform, repurchase, refactor, retire, retain. And they were first out to shoot. This is not necessarily wrong, because you have a business who's trying to figure out if they're red ocean, blue ocean. Are they trying to get more of the market they're in or expand into new marketplaces? And in that kind of a change, it's an opportunity to really refactor the workloads, refactor the applications underneath it, maybe purchase new products that help them get into a new space. They may be rehosting because they're looking at costs of brick and mortar, CapEx versus OpEx, essentially. They could be looking at sort of the four futures sort of view of the world, where you see systems that are all controlled by end users versus systems that are centralized, and they work through these options. And retiring versus retaining is a certain possibility. The cloud, as we know it today, is a globally distributed computer, just one. It's not a whole bunch of computers. It is one globally distributed computer, which means we need to do good distributed computing. And while these things are great recommendations, and they were, like I said, first out of the chute, I think they may be a little off kilter. So I would provide a different point of view. And bear in mind, I think Gartner's great. I would like to put these in a new light. Rehost is really lift and shift. You took it from one host, you put it on another. Nothing changed. You moved your problem, but the problem still exists. Replatforming is the same thing, except you have gone in and tweaked it some to take advantage of a new platform. Re-architecting is an investment, and largely an expensive one, but usually worthwhile, but you dump money on the problem. Repurchase and retire, they're two forms of abandonment. You either cut the funding off and replace it with a cost product, or you retired it altogether and just let it wither and die. Refactor, that's work. Recode, rebuild, redeploy. And retain, retain is just suffering, where you say we're going to keep it in place and let it be, we'll just live with it. That's LIARS. That's kind of how that works out for me. I think that this isn't necessarily bad. The idea is you need to have a business decision to choose among them. This isn't a technical choice anymore. The question is, where do you want to spend your money, and what does your future look like? So there's a gentleman named Barry O'Reilly, and you may notice a subtle shift in the presentation here. Barry is a very smart man who used to work with us at Microsoft and has gone off to get his PhD in, honestly, I think it's philosophy and computing. He's really smart. He has his own little company called Black Tulip, but he is a PhD teacher in Sweden. Anyway, I'm going to restate some things that Barry put out, and I apologize to Barry in advance. I'm sort of abusing it to get it into a short period of time. I've got references at the end of this deck to all of his stuff directly, and you can just look him up on YouTube. He does amazing presentations. But the idea that Barry had was that there was a different kind of problem here. And it said, we've gone from these systems that were very ordered into systems that are very disordered. And if you've been listening for the last almost half hour, that's exactly what I said. Barry and I agree. And weirdly, he has managed to find the formula behind the things that some of us have done sort of instinctively. The highly ordered systems were very, very predictable, and they could be tested in a predictable way. The real systems that we're doing nowadays, these disordered systems, it's not disordered because it's bad, it's disordered because they're human. We have loose coupling everywhere. We have unpredictability everywhere. And we bring humans into this conversation. So all that volatility, uncertainty, and ambiguity trickles down into this core essence. What we used to do as structured engineering is not what we do today in large system development. So Barry came up with this idea. Instead of building something to requirements, we can take a problem space and apply these really random simulations to it. Now, he has a bunch of really good math I'm not going to try to repeat that is statistically based and has proven these things to work. He's used it in the real world too, so I'm not just making this up. I've actually asked him to come onto my current project to help me because it's great. But he came up with the idea of these stressors. So if I have a system and it's about parking cars, you usually would say, well, I have to have so many spaces, and I have to have so many cars of so many types, and the car types are like X. His response would be, what happens if Godzilla comes through town and steps on your parking lot? And it sounds absurd, but the stress that would introduce in your system to deal with that forces you to look at things like resiliency and scalability and scale units and composability, and all these things that we go after technically are sort of driven to the surface to deal with these completely random events forced down onto a fairly normal problem space. It takes us out of that engineering mindset and puts us into this sort of, how do I deal with dependencies? How does the world work? For him, there's three types of coupling. There's dependencies, interdependencies, and these sort of tight coupled, loose coupled problems. Being able to work through those as a matrix and weight them out appropriately is what he brings to the table. So residuality is about inducing this unexplained circumstance and looking at the number of connections and nodes and the kind of connections among those nodes and trying to figure out how to deal with that problem. What it drives us to is a few do's and a few don'ts. And I really just ripped off Barry's slides here. So again, thank you, Barry. On the do side, it's got to be able to survive known and unknown things, these extremes. It has to be able to function under almost any kind of environment and expose the holes to the business. Because in a parking example, the problem isn't that you can't park one more car. The problem is that your business can't make any more money. That business has a belief of growth and some future strategy. And you have to deal with that as part of this. What we're going to try to avoid is this like hardcore requirements engineering that we did in 1980 and 90, and turn it into making predictions about capability instead of predictions about the future. I want to be able to see how things act and react, not have a certainty in my design. A lot of systems that are currently wandering zombies really miss these functional requirements. They didn't look at the ilities, right? Scalability, manageability, reliability, resiliency, security. That's all comes to bear. When you look at this through Barry's lens of residuality, you have this opportunity to really twist things around so that they are forced into place, where you've got to actually deal with that problem set beyond, can I put one more car in there with one more meter to charge one more dollar? Now, again, I don't want to beat Barry's stuff to death. He's a really brilliant guy, and I strongly encourage you to go look up his stuff. But we still need to fix it. So fixing the systems and looking at the next set of systems, the R's start to look different. Instead of, removing something or living with it, we need to re-architect it. We need to design it. We need to recode it, and we need to redeploy it. And by doing that, if you look at it through this sort of uncertainty lens, you have the opportunity to readdress the underlying concerns, which probably are years old and no longer valid. But the business has grown some since the last thing was deployed. Since it was deployed to a desktop as a client-server application, certainly. And if you look at re-architecting, is client-server still the right answer? It may be that now you want to use virtual desktops and cloud-based data. So it's still client-serverish, but it's in a different environment, not just re-platformed, not just re-hosted, but literally re-architected. If you're testing for chaos throughout this, you're going to end up with a whole new version of the same architecture. The steps might be the same, but the implementation changes. You get the opportunity to look at continuous integration and continuous delivery, which in an old school, we had release management, and there was a stopping point and a predicted release. We also released into boxes, and we shipped them, and people did installs on those. And we had no feedback from that installation. It either worked or it didn't. And if it didn't, some users would complain, some users wouldn't. Now I have telemetry throughout. I know what's being built. I know when a feature comes from all of its parts, and I have enough of it to deploy a unit of work to someone for value. And I have telemetry that can track the value as well as the technical implementation from the moment they try to deploy it. And that person's deployment is discrete from the next person's deployment. I may be deploying in South Korea with a language pack and in South Dakota without one. As these things work through and we're decomposing the problem so we can make it through this continuous process, we have the opportunity to create shear lines. And if I don't see shear lines in a process, that is units of work that if it breaks over here, but not over here, right? That there's a boundary that we have chosen to put in place, like the crumple zone in a car. It takes the impact and it sort of gives up its life. So the passenger compartment never takes the hit. Software is the same way. We can create shear lines that allow us to break on versioning or external dependencies or some other unknown piece of ambiguity that we probably found out through this residuality theory approach so that it can survive and be patched or be revised or actually versioned. That major minor patch process that we used forever still exists. But if your software can't survive the change, if everyone's a new version, you aren't in the modern world anymore. You're just building a zombie from birth. Just craziness. There's also this concept of cost in a modern application. When we go to re-architect something for cloud, first of all, cloud native is the gold standard. If you can do a cloud native application, you're calling functions within your cloud, whether it's AWS or Microsoft or Oracle, and you're allowing that organization to do all the rest of the work. And it's a lot of work to make sure that instance exists, to make sure another one comes up if that one goes down, to make sure you have backups, to have multiple network routes, to make sure your data actually hits the platter and is written cleanly before a transaction ends. That trust in that infrastructure is what manifests when you use something that's cloud native. But there's a cost in code that has a return in the real world. If I'm looking at somebody's code and it has no instancing, like if there isn't X, make X so I can call it, then I know they're old school and they're a dead man walking. If that same thing calls an instance, creates it, but never tears it back down, then I know they're just a very expensive desktop application being rehosted on cloud. Cloud charges you a lot of money to keep things running. It's really good at it. Charging you money, that is. If you don't turn your stuff off, you keep ringing the register for whoever runs the cloud. If it's Microsoft, I thank you. But you don't have to do that. You can make things that have their life cycle baked into them. It's at the code level, and the evidence is in that code. And all you have to do is go look in source control. There should be the creation of a thing, the destruction of the same thing whenever its thing is done. Handling state and statelessness making a lot of small pieces, not like lots of giant ones. These are all indications of whether things are going well or badly. Being able to have automation between environments is part of the life cycle that raises flags. If you go from dev to smoke to test, to staging to production, and each time it's being done manually, you're doing it wrong. The automation that you do from dev to smoke and smoke to test is where you learn to do automation. And then that automation pipeline moves with your binary, your product, as it goes into production. So that not only can it be called to deploy, but it can be called again to deploy again. See the last 5 minutes where we talked about creating new pieces. If I want to go, red, green on a particular kind of thing, I want them to come through the same deployment pipeline. Similarly, I want to see that there's policy applied and governance. Are there controls to this thing as it moves through the pipe? Each of those deployments should be subject to some form of policy. That mature release management allows you to do an even higher level thing that is miraculous. Affectionately called FinOps, right? We've got DevOps, we've got SecOps, now we've got FinOps, which is finance. Are we keeping track of the cost of doing this thing to make sure the business still gets value for it? That's not just the cost of code, although it is. And it's not just the cost of running it, like I said, creating an instance, tearing it down, but it is. It's also the long-running cost to the business. Are they getting the market value they expected? Are they seeing the things that were intended to turn out on the business side? Do I have business telemetry that feeds back cost and revenue and net value? You should. If I'm looking at code and there's no telemetry, if there's no back-end telemetry system, then no, you're not done. That's the hard work that you do up front so that these other things work on the back end. And any good cloud system has to have it. As it turns out, most of the cloud providers provide you some form of telemetry tooling. You just have to turn it on and then put the hooks in the place where it's necessary. So we've made it through automated development, automated release promotion. We've got FinOps, making sure the business is happy. There's 2 more pieces. First one is COOP, continuity of operations. Writing software that runs is barely the problem. It's having a business do a thing for a long period of time and sustain loss, change, volatility, uncertainty, and ambiguity. Continuity of operations is kind of the last line of defense for that. If your data center goes down, if your network connection goes down, if your service provider goes down, if your backups were malformed, if you can't redeploy one day, if I have users who move to something completely different from what they've been using. Those ifs, that's your COOP plan. And you can go as far out as what happens if a meteor hits our data center, and as small as what happens if I lose a power supply. That's on the physical side. Then on the software side, there's what happens if I have a spike in demand? What happens if my instances fail to unload out of memory? What happens if my data system gets sluggish as the data set grows? Making sure that you can survive that and survive the change required to fix that is part of continuity of operations. And the last item is service independence. Again, I work for Microsoft. We have Azure. Azure has now hundreds and hundreds of small services. They all run on a singular, globally distributed computer. And they are all independent. I can put one in, I can take one out. I can manage them, secure them, encrypt them, all independently, and they don't affect the other. It's a design principle that spans everything. Modern systems do that so that they don't become zombies. They do that because that allows them to lose a limb and then grow it back and become regular people again. Each of the independent services scale in their own way, and as an aggregate set of subsets can create scale sets, scale units, so that your business can grow in a predictable way. Having service independence gives you opportunity. The more dependency you have, the more coupling you have, as would be found by this residuality theory, the harder it's going to be to survive these crazy changes. And most of these changes are unknowns and unknowable. It's complex. That volatile, complex environment that we live in software every day is not getting better. It is getting worse. But there's proof points, what you can do. Now, I mentioned earlier about governance. Weirdly, I'm a software developer who likes governance. The problem is most of the places I go to don't govern themselves. And you can't govern from the bottom up. If you're part of software development, you're at the bottom of the stack. Somewhere, there's someone with strategy. And that strategy has to manifest itself into guardrails that you work within. It says, we're going to go grow this way. And because of that, we're on these tools, working in these environments. And with that, you're going to build a solutions that serve some people. I do a lot of sort of front-end development discussions. And I don't mean UI, I mean the beginning of the life cycle. And it breaks down to a simple phrase. Who does what, why? 3 parts. Who, what, why. The reason this is important is if there's no who, there's no reason. Don't build it. If there's no why, it's the same thing. Don't build it. The what, that's the mechanics that are responsibility of the software in between. A lot of software no longer supports the people it was originally intended to, but there's no governance coming around saying that actor type, that persona, that business unit has been shaved off. A lot of businesses grow and die on mergers and acquisitions, and the software built to support something when it's thrown away, sold off, remains and becomes a load on the legacy system and technical debt. Governance manifests in policy, so there ought to be evidence of a policy engine, somewhere where people in the business can codify policy, and have people in the automation side apply through automation that policy so it's imposed on the software development environment and on the deployed environment in production. The policies may be as simple as you're not allowed to open port 40, or it could be as complicated as requires human review and cannot go forward unless signed off by these 6 roles, and then have some sort of chop chain automation in between. That policy engine should be clearly evident. If it's not, the business has either turned its back on IT and they're building without a who or a why, or it's a legacy system that they just are too fearful to try to apply policy to. The architecture reflects the organization. Governance has to align with the architecture, and the architecture has to align with the governance. It sounds a little bit rhetorical, but architecture determines the guardrails between which software occurs. We create the scale units, we create shared points, we create all of the controlling telemetry that is imposed on the rest of the development community. If the organization is not using its governance through its architecture, there's no reason to believe that it's ever going to get implemented. Similarly, those architects aren't there to just impose policy. Architects, in my opinion, have to go down into the team, work directly hands-on with them, so that they see the opportunity in the supporting architecture and the value of those underlying policies. And with architecture and policy, they can actually go faster, do more, and do it for less. If you can't achieve these things, faster, more, less, there's something wrong with the architecture of the policy. And it's not up to the team to fix that. That moment in time, that project team's job is to get their work out the door. And if architecture's in the way, they deserve to ignore it. And the architecture team's got to go back out and figure out how to make it. So using them makes it faster to do more, cheaper. Last, dependencies and constraints. They're more important than known requirements, because requirements are those static things we've been doing since 1990. Dependencies and constraints are dynamic things that weren't knowable but are true. You can make them visible through some of these activities with things like the residuality chaos work. And you have to be able to adapt to them when they occur because they're real. That constraint might be that an industry like the finance industry comes out with a new law, or there's the SWIFT network behind financial transactions, and they've decided that you have to package a financial transaction a particular way through as the currency exchange happens. Or I did the F-35 stuff for a brief period of time, and Turkey left the coalition. You have to be able to survive cutting them out. That's what the business needed, and it had to be done. But those dependencies, what that country took on the system and what the system took on the country, they have to be made in a way that when you cut that out, you're not hurting everybody else. So you're governing with intent. Remember I said at the top, one of the things we had was ambiguity. And part of the problem is there was no intent. If the intents are clear and people govern with those intents, then codifying those things into practices and policies becomes just an exercise of work. It's complex. We do the work. We end up with a thing that we can really go off and work with. So kind of a thumbnail view of what makes things live in a world of Vuca. X as a service means that you're capable of creating services that are discrete, right? They're atomic. It's a concept as old as compute. Things have a beginning, a middle, and an end, and you know how to scale them and kill them. You have to be able to engineer in a way that includes composability, even if you don't do composability. So you have APIs and facade patterns. You look into the source and you can see that there's external callers that are sort of not external because they have awareness of your facade and they know what that interface is. Or legitimately external people who are working off some sort of API that they can discover and then work with later. Business alignment telemetry, they need to track to OKRs and business metrics. And I know this is usually way out of the scope of traditional software development, but if you don't know the OKRs for the business you're serving, you don't know why you're having a thing do something. Meeting those OKRs is the goal of the business, and you're supposed to be an enabling platform for that, not just a cost that they have to figure out somehow how to write off. Operational costs are considered throughout the development cycle, and the development cycle ends when the last user dies. And this is where, we're trying to avoid the zombies. If I'm clear about what my costs are and the benefits and the trade-offs from architecture through design, development, deployment, then feedback into that loop again, DevOps, manage through policy, constrain through governance, back out to the people, use, feedback, do it again. If you have these things, you're a modern product. You're going to run in the cloud and you're going to run in the cloud well. And the cloud will be there not as an expense or a burden or a problem to be solved. The clouds are there to enable these characteristics. And they provide you the tools and the opportunity to do that if you choose to use them. If you don't, well, you're on your own. And you can host on a server in the cloud and control all these parts. You can't quite hug your hard drives anymore. And you really can't use the network as a security boundary. But you can still do well-known 1990s, 2000 client server software. It will work, but it won't survive. Of course, it also won't die. Instead, it will come clawing its way out of the ground like a good piece of zombie software and try its best to eat your brains. That's kind of a dark note, but yeah. So that's it. That's why I see Vuca as important and the way to identify it and a few things you might work on to get away with it. Thank you all for giving me your time.
Stephen, we thank you so much for presenting with us today.
Thank you. Always a pleasure.